Welcome to Make Me Data Literate, the podcast that makes data intelligible from the Australian Data Science Education Institute. We're on a mission to make the whole world data literate. I'm your host, Dr. Linden, and every week I'll interview someone with a wild and wonderful relationship to data. Let's see what we can find out. Welcome back for another episode of Make Me Data Literate. Once again, I am indulging myself and getting to interview a super awesome person. This time, my beautiful friend, Linden Ashcroft. Dr. Linden Ashcroft, I should say. Welcome, Linden. Thanks so much for coming on.
Thanks for having me, Linda. It's great to see you and hear you.
So, can you introduce yourself? Let us know who are you and what do you do?
Yeah, absolutely. So, I am a lecturer at the University of Melbourne. I have managed to cobble together what, in my mind, is a dream job. So, I spend half of my time teaching people about weather and climate. I'm a climate scientist by training. And then I spend the other half of my time teaching students, graduate students, about communicating science. So, these are students who study all sorts of science, from chemistry, pure mathematics, health sciences, applied biology, all sorts of things. I work with those students to help them communicate their work as best they can, not necessarily to the public, but to each other. And so their research can change the world. And I've kind of built this job based on things that I have always enjoyed throughout my career. So I studied as a meteorologist in atmospheric science and physics and maths. And then I kind of went away and did some science communication training. And then I got lured back into university and did a PhD. And then I worked in the non-for-profit sector for a while before going back to the university sector. And then I worked in government for a little while. And now I'm back in the university sector because I feel like it's a space where I can do all of the fun stuff and not quite as much of the less fun stuff. So I get to do all of the things that I love. And that's what I do. So I do a little bit of climate research on the side as well. As a scientist, I'm a historical climatologist, which means I work with old weather observations, old books and newspaper documents and archives and those kinds of things. I generally look at the old numbers in those documents and try to assess them for quality, see what they can tell us so we can extend our understanding of past climate, which will help us get a better grip of what's going to happen in the future. So I do a little bit of that as well in the other half of my time. I think I've already committed a maths faux pas in the first few minutes, but that's what I do. That's who I am.
I love that angle of historical data because, I work a lot with the kind of data that you get from sensors and things, and they have their unique let's say quirks, sometimes flaws. I downloaded the data from my Apple Watch the other day, and in some places I was looking at my heart rate, and in some places it reports my heart rate to 4 decimal places. And I really don't think any of those decimal places are justified in terms of the accuracy with which the Apple Watch tracks my heart rate. And in fact, I don't think decimal places are probably ever justified in a heart rate recording. I imagine you don't get historical data to 4 decimal places, but it must have its own kind of oddities.
Absolutely, yeah, it definitely does. You do see some pressure observations, so atmospheric pressure observations I have seen to 4 decimal places now you mention it. But again, I
Wow.
wouldn't go trusting all of those. I think it's because, so back in the 19th century, the big barometers, now it's all sensors, but you'd have these huge mercury field instruments and you'd calibrate them precisely, and then you'd also have to check the temperature of the air precisely because that affected how the mercury behaved and how the glass behaved and how the wood behaved. And then you have to adjust for gravity, and then you'd have to adjust for whether you had transported that instrument on a horse over mountains for a couple of days. And then you would
Wow.
finally end up with a value that actually, now you mention it, would have sometimes 2 to 3 decimal places afterwards. And then it's our job in the 21st century to take that, convert it back into observations that we can compare as best we can with modern records or records that were taken at the same time, so we can kind of build up a map. and understand, yeah, what we can trust about them and what we can't trust about them. Like you say, all data sets have their foibles, and old weather records are absolutely no different. That's one of the reasons I love working with them. I got into weather and climate science because I love the atmosphere. I was always fascinated by the sky growing up in country Victoria, and I really wanted to study meteorology. And then when I got towards the end of my undergrad degree, I kind of thought, no, climate, that's so fascinating. It's amazing to me that you can calculate statistics over time and see changes, and the weather in one place of the world can affect the weather in the another place in the world. That's incredible to me. And also climate change is obviously something that I'm really passionate about. And so I got into the field because I was interested in that. But the more I dovetailed the things that I am really interested in, this climate science and communicating, I kind of realized that the stories behind the data or the stories behind the science are a way to really to connect people. And the things that we don't often see. There's so many graphs that exist about climate change. There's so many acronyms, and there's so much data, as there should be, as it's a huge problem, and we need as much information as we can get. But um, behind so many of those are people taking these weather observations. Even today, the Australian Bureau of Meteorology's rainfall network, yes, there's lots of automatic weather stations, but there's also lots of volunteers who go out every day at 9 o'clock and check the rain gauge, and that information gets fed into the Bureau system, which then builds up their databases, which then informs how accurate their predictions are. That's people, and it's the stories behind those people that is super important for how much we can trust the data. And I don't know, it's really fascinating for me. I really love working with it. It's messy, but it's super fun.
I love that insight about the stories being important, because we know, the whole thing about people saying, oh, well, if you just show people the data, they will change their minds, and we know that actually that's not the way it works, and sometimes it can actually be counterproductive, and that stories are how people really connect with science, and how you can change people's minds. I remember I think it wasn't the first time we met, but the first time you came to the school I was teaching at to talk to the students, and you spoke at assembly, and I reckon I could pretty much tell the same story because it stuck in my mind so much. It was such a great story, and I won't get into it because otherwise the whole podcast will just be that story. But it was so powerful and so effective, and that was pretty much your whole talk, and it wasn't what I expected at all, but I was just standing there with my mouth open going, oh man, she is good, that's amazing. It was phenomenal.
That was it. I love that story. I bust that out whenever I get an opportunity. And it was about data collection, right? It was about
Yeah.
a passionate person who really cared about the thing that they really cared about, and so they went and they explored. And it was a small person. It was a little kid who was really passionate about wombats, and so they went and they really collected more information about wombat burrows than anybody else in the world, and they ended up publishing a paper about it. And it was yeah, I'm telling it badly. I've told it better for the students back in the day. But again, yeah, it's about the story behind the data. And when we work with historical weather data, historical climate data, you've got to understand where these observations came from. And in some cases, why these observations were taken. Was this person, a lot of the weather records I work with come from early white settlers, right? So I'm talking about quantitative information here. I'm not talking, unfortunately, about Indigenous knowledge and Indigenous climate awareness, because that information runs so deep and is so much more detailed, I would say, than the quantitative information that we work with is in modern climate science so far. That is a thing that's changing in my field, and that's really great. But what I work with at the moment is white invasion observations from 1788, pretty much when white people came. But a lot of them were taken by early colonialists who wanted to understand this new place, right? And they wanted to get the best handle they could on the rainfall, on the temperature, on the variations, and so they could succeed this new environment. And so to me, that kind of you have to put that layer of understanding on top of the observations when you're looking at them. There's other observations or there's other information about past climate in Australia that you have to think of in a different way. So, for example, there were all these famous ads in the UK in the late 1800s, I think it was, saying, "Come to South Australia. Adelaide's the best. There's no convicts here," right? Adelaide being the free settled city in Australia. There's no convicts here, and the weather's amazing. It's never too cold and it's never too hot. Come to South Australia. And that's bullshit. Like, we know. Adelaide gets some of the worst heat waves in the world. I recently did a study with some colleagues looking at really, because we've got beautiful weather observations in Adelaide back to 1836. And then it was really hot there. There's lots of devastating heat waves, and people have died, and zoo animals have died, and the history is very rich in heat waves in Adelaide. And that information, a bit more reliable than the information that you get from media outlets in the UK at the time. And so for me, the work that I
Some things
do,
haven't changed.
well, yeah, that's true. But it means kind of being a bit skeptical, thinking, where is this information coming from? Why are people collecting this information? Is someone recording it because they're passionate and they really care and they really want to understand something? Or are they doing it because they're being paid or because they are a convict and they're being told they have to? Maybe you would put a little bit less faith in that kind of information. But you don't get to that until you've explored the data behind the data, the stories behind the science. And that to me is really important.
That's one of the things that I always look at when I first introduce a data set, whether it's with students or teachers. The sort of first two conversations are, what is this data? How is it collected? But also, what's wrong with it? And I feel like that's not a conversation that's often built into the way we teach data. Often, like, the maths curriculum at schools is, here is a data set, apply these statistical methods to it and make these graphs with it. And there is no conversation about that, the origins of the data and what might be, the foibles and what might be, why it was even collected. What are we looking at here, trying to understand the context of the data. I worked with a seagrass data set that I didn't understand it at all at first. And when I talked to the researcher who collected it or had it collected, he explained the way different parts of it were interconnected. And, like this particular seagrass, if it's growing at this depth, it means the water is murky because it it will only grow really deep because there's no light there. So if it's growing shallow, it means there's no light getting, so there's all of these things that you can't possibly get out of the data unless you understand the context.
That's so true. And I think in some cases you can only do so much, right? You can't be across every little thing. Maybe you can when you get to a certain age, but even by then the knowledge you had has been surpassed by new knowledge. But in my field, at least, you'll have people who are experts in prepping the data, in getting the data from a beautiful old handwritten document into a place where you can then kind of convert it into a format or analyze it enough so it's useful for the next step, where people can then use it in big computer models that represent the atmosphere behavior in the past, or they can use it to understand what was happening at that location over time, and then the next person can take it and conduct the statistics on it. It's quite, I think in some respects you have to black box it a little bit and trust and say, okay, well, that person has done their best to prepare the data for me in a way that I can then do something else. But you're right, it's not really, that chain is not often taught in maths, I guess, because they're, well, I don't know. You know much more than me. It's about getting the skills across, isn't it? And maybe the critical thinking or the skepticism. I mean that in a healthy way, not in a we can talk about that a bit later, not in a
I
kind of
like,
conspiracy theory way,
yeah.
in a healthy way. Maybe that, I don't know, in education is that kind of put more in the English space or in the humanities space, and not so much in the
I I think
mathematical zone.
it's not put anywhere in
Hmm.
sufficient quantities. Not that it's not there. I know that some teachers do teach critical thinking and teach it really well, but um, it's not integrated in an effective way. And I I like your distinction between skepticism and you know skepticism with a K, perhaps. Um, um, but it's I like to call it rational skepticism, where you're applying your critical thinking to the evidence, not to something some dude said on YouTube once.
Yes. As you say, it's about what's wrong with these data, like the first step
Mm,
when you see. So I've got a student at the moment, we're working with some beautiful observations from Perth. We've recently, so a lot of work about finding old weather records in Australia has been on the East Coast. That's where white people settled first. We've got
mm.
the longest sort of written record there. And we've found lovely observations back to 1788. William Dawes was a lieutenant on the First Fleet. He was an astronomer. He came over to ostensibly observe Halley's Comet. He didn't really see the comet, but he did record 3 years of weather observations right where one of the pylons of the Sydney Harbour Bridge now sits, was the first
Wow.
um, Western observatory, I guess you would say. So we have a lot of observations, but not a lot's been done in WA. And then over the last few years, I'm working with some colleagues and also citizen scientists, volunteers as well, have helped us rescue these data for Perth back to 1830, which is
Fantastic.
incredible. Yeah, if you think about where Perth is and you think about the weather that we get in Australia, it moves from west to east, and
Mm,
having weather observations in Perth back almost 200 years lights up that whole section of our hemisphere. The southern hemisphere is so underrepresented in every climate data set that exists, that is used to calculate statistics about how the climate is changing, to figure out what's going on with our clouds, what's happening with our storms, what's happening with our heat waves and our droughts. The southern hemisphere is just so underrepresented. So these data are really exciting. Anyway, my student's working with these observations and he's starting to pull out some results now, and it's really exciting. But I always find that when he shows me a graph, my first thing is, oh yeah, but what's wrong with the data? They're like, that looks interesting. Is there a mistake? Is there something
yeah.
that we've missed? Is there a change in observer there? Is there a change in protocol? Maybe they broke a thermometer and they needed to replace it. And so there's a change that's not due to something to do with the climate, it's due to something else. And you need
Yeah.
to dig deeper and deeper and deeper and deeper. And I think he gets a bit annoyed about that, but that's kind of, that's what you need to do. You got to be skeptical. You got to make sure that you've eliminated all other options before you can confidently say, oh, I actually think this is a signal of something else, of something changing.
Are there times when you just can't be sure?
Oh, yes, there are absolutely times when you can't be sure. And the thing about doing this in Australia is that our climate is so variable, right? So we
Mm,
swing between droughts and floods, as we know, very melodramatically, like we do. But that affects the record as well. So let's think, going back to my PhD now, I did some work looking at the 1840s and 1850s. And if I was to just apply a statistical approach to tell me, oh, are there any problems with these data that statistical tests can identify? Um, the programs found a few. They were like, oh, in the 1840s, there was a big jump in the temperature record here that doesn't look right. Maybe doesn't make statistical sense. Um, and I thought, okay, could be a problem with the observational approach. There was lots of changes happening around the world at that time about the best way to take weather observations and stuff. But there's also a big switch between wet and dry conditions. And if you've got a big change from being a dry period to a wet period, then you've got grass that's gone from being brown to being green. You've got an increase in cloud cover. So that's going to change your temperature record as well. And it could be
mm,
that that change was so big that it shows up as a jump in the record, which could be statistically picked up as a change that's not in keeping with the statistics of the rest of the record. So that is unsatisfying, right? To have to say, we're not quite sure, but these are a few hypotheses, but that's kind of what we have to do, because you can only know so much, I guess, about what you're seeing when you go further back in time. And that's why using other sources of information, you know, tree rings, ice cores, coral skeletons, all of these natural records of the climate's past, as well as documentary data, letters from people, newspaper articles, different summaries from different societies and those kinds of things. That's kind of secondary information that you can use to validate your hypothesis. Oh, you make me sound like a scientist. Validate your hypothesis. I'm
That
happy to have
wasn't
said
me.
that on
That,
here.
that was all you. Well, so did you find this is like there's so many aspects to what you do? It's you think of often we often think of science, I think, as sort of doing one thing and doing it really intensely. Standing at the lab bench doing the thing or whatever. There's so many different aspects to what you do. Was there anything that you felt was missing from your formal education that you had to kind of cobble together on the fly or go and figure out for yourself?
You're going to be very happy with this answer. Programming.
I did not set
Programming.
that up.
I promise that Linda didn't pay me to say that. I did a physics and maths degree and an atmospheric science sort of double major. I also did a English literature diploma because doing pure maths and physics wasn't great for me. It didn't bring the best out in me. I wasn't enjoying any component of it. I needed that extra part of my brain to be used. But when I got to doing my PhD and doing my job and I wanted to answer questions, yeah, I had to teach myself how to program, and that was really inefficient, I think, and clumsy. And I know there's lots of scientists, there's lots of excuse me, there's lots of scientists who are in that boat. And you
Yeah,
learn,
I hear
and
it a
that's
lot.
fine. Yeah, and once you've learned one programming language, it's easier to learn another programming language. But I think I would have benefited from just like learning a language you speak, right? From somebody teaching me the basic syntax so I wouldn't go around offending people and butchering something that could be done quite elegantly a different way. I reckon programming is, and that's what I encourage students to do now. I get people coming to me saying, I'm really interested in this, or I really want to do climate stuff, or I really, really want to do weather stuff. And I think that's just even one subject, introduction to programming, is something that you could never, you won't regret that.
Yeah, yeah.
Because
I
it allows
often
you to work with small data sets, big data sets, answer big problems. The work that I do range from working with tiny little time series all the way up to huge ensembles of, 80 different runs of a representation of the atmosphere that's got, I don't know, millions of points in it, right? Because I try to understand how our weather is and climate is changing, and you need to be able to use the tools to do that accurately.
yeah, it astounds me that programming and data are not core parts of most science degrees now. It feels like it's way past time that we were building that into the people's fundamental education, because if they're going on to do science, they're going to need it.
Yeah, I agree. And I find it fascinating that the field of data science, as you well know, is kind of just growing and growing. And I wonder what it's like out there now if you come to an organization and say, I've got all the data science skills, I've got all the programming skills, but I don't have the subject matter skills. And then you have people saying, I've got the subject matter skills, so I know all about dark particle physics, or I know all about how thunderstorms are made, or I know all about how platypus populations work, but I don't know how to model that in a data set. What you need there in the middle is the ability to communicate with each other,
Yep,
right?
yep,
Um, like
100%.
I like I said, you can't be across all of those things unless you want to. I mean, you could maybe, but you'd probably just feel like you're doing a terrible job of everything, which is maybe not too far from how I often feel in my career at this stage in my life with a small child at home. But yeah, that ability to take one person's jargon and another person's jargon and be able to build a bridge between those two is so important. So important. So even if you haven't had that programming training, you can say, here's the question that I want to answer. And the person who is a data science expert can say, okay, well, here's a way that I think we can approach that. That's so important to do.
And communication is another thing we've historically not been very good at teaching as part of science. But I feel like there's hope there. I spoke at Pint of Science a couple of weeks ago, and the other two talks, there were three talks that night, me and two other people, and the two other people were incredible. Like, I was just spellbound. They told beautiful stories. They made it really accessible. I was like, wow, if these are the scientists we're producing now, then we're doing much better than we were.
Oh, I'm so glad to hear that. And as a natural extrovert, I would say, as someone who doesn't mind getting up and speaking to a crowd of people, or I love talking about what I do, I sometimes feel that others will think, oh, that's not for me. I'm not kind of, that's not my personality, or I'm not really
Mm.
like that. But what I see more and more, and what I realize is so crucial, is that we're not talking about everybody becoming Dr. Carl here. It's,
Yeah.
it's about being able to distill your information or tell your story in a way that other people will connect with, but while being true to you, so in our
Yep.
communication classes we get students to do a lot of writing practice and a lot of presenting practice, and the best presentations aren't always the ones that have big jazz hands and
Yeah.
huge facial expressions as I'm doing to you now, but the ones that are true to themselves. If people are quietly spoken, or they tell a story that's not necessarily connected with my research is going to save billions of dollars or save
Mm.
billions of lives, but this is something that I'm really interested in and I'm passionate about it because it's fascinating. And here is why I think it's fascinating, and here is what I want to tell you about it. They're the stories that really connect with people. So I don't know. I sometimes worry that the people who are excellent science communicators, they all sort of sit in this extroverted sort of box, which is maybe unfair. Maybe I'm sort of a bit out of the loop, but there's a space for everybody, is what I'm saying, and you just
Yeah.
need to find the way to tell your story that connects for you. Does that make
And I
sense?
think, yeah, absolutely. And I think the idea that you need to tell stories that you're passionate about is key. I sometimes get requests on my blog to write about a particular topic, and if it's not something that I feel passionately about, I just won't do it because I know that I won't do justice to that, and I won't. A lot of my blog posts kind of pour out in about 20 minutes and then get a quick buff and polish and I hit post because it's all in me, it's really intense, and something I really care about, and that's how it works. Um, is there one thing that you wish everyone knew about data that, if this one thing was better understood, it would change everything?
Data are messy, I think, is the one thing. One That's something I wish everyone knew. It takes a long time to get the data from wherever it is to when you see it in the finance report at 20 past 7 on the ABC News or wherever you get your graphs from. Um, Data are really messy, and it takes a long time to get them into a format that can be understood easily. Not just, my example working with paper records into big data sets, but even if you're working with a big data set, I
Yeah.
see students who they spend a lot of their time just getting it from one format into another format, and I think, oh, I'm so sorry. That's kind of what 70% of science is. It's making the data into a format that's useful for you. I'm so sorry. Good luck.
Yeah, and
Yeah.
that's hard because it's not the fun part.
No.
You really have to wade through the weeds before you get to oh, we found something.
Yeah.
And sometimes you wade through the weeds and don't find anything at all, and that's
So true.
heartbreaking.
Yeah, so true. And I guess that's the other thing. Like, data are messy, but they're also, a lot of them have been taken for a purpose, and you have to think
Mm.
about how that purpose fits in with your purpose, why you're interrogating the data. So back to weather and climate observations, for example, I'm saying weather and climate because some people you just want to know what the weather is outside right now. You've got a weather
Yep.
station in your backyard, or you're looking at the app, or I don't know, you just want to know what the weather is today. But to observe the climate, you need to have a weather station or a satellite or any kind of observational system that is consistent over time, over a long
Mhm.
period of time. And that goal is very different to knowing whether you should take an umbrella outside or not. And
Yep.
and when you're trying to use one sort of information to explore another sort of question, it's not impossible, but you've got to be very careful.
Yeah, and that awareness of, well, it's proxy data really, you have the data that you've got, not necessarily the data that you want. How can
Yes.
you use that data to not get the data that you want, but at least get some information that is close to what it was you were looking for? It's I think there's a trap there when we go, I use this data and produce this result and forget that the result isn't necessarily as solid as we'd like it to be. And there are problems with it because the data was not the data that we really needed for that purpose.
Yeah, so many conferences I go to or summary reports that I read, the answer at the end of the big discussion of this room full of global experts is, we need more data. We just need some more please. We need more sensors, or we need more information back in time, or we need a larger network, or we need more satellites. And yeah, that's because so many questions we're trying to answer, we still can't answer accurately because we've got such a dearth of data. We don't have enough information. Um,
Yeah.
yeah.
Have you seen some bad data mistakes? Are there some that stand out for you where you go, oh yeah, this is the worst mistake I've ever seen?
I think that takes us back to this idea of skeptical with a capital K. Did you say? Um, so there are lots of observations, as I keep saying, that exist before the Bureau of Meteorology was formed in 1908. Lots of weather observations. But as we were just talking about, a lot of them were taken maybe for a different purpose or taken in a different way, or particularly temperature observations, and particularly in the 1860s, 1870s, 1880s, 1890s, lots of weather records in Australia were taken in a way that is quite tricky to compare to modern observations, because the way that the thermometers were housed, thermometers normally live in a white box. You see them all around Australia. Thermometers live in a white box called a Stevenson screen, and these boxes have been the global standard for over 100 years. But they're not perfect, but they're the best we can get, where the thermometers are protected from the rain, that they still get enough airflow through that they can accurately record the actual temperature of the air. They came into play at about the start of the 1900s. And before that time, thermometers were kept in different kinds of things. There's stories about thermometers being kept in beer boxes, under verandas, in a different kind of box that was open on one side. And if you didn't move it correctly throughout the day or throughout the year, then sun would get on the thermometer, so you wouldn't be as accurately recording the temperature, or it's quite difficult to compare. And you kind of need to know that to work with these weather observations. But that doesn't stop people who really are desperate to find proof that climate change isn't happening. And I think that's the stage we're at now. You've got to be really, really desperate to want to find that information, because the evidence is absolutely so overwhelming in every single part of our Earth system. You don't need thermometers, you don't need weather observations. You can see it in every aspect, from plant behavior, animal behavior, glacial behavior, sea level behavior, it's everywhere, right? It's happening. We know it's happening. We know it's bad. We know it's us. It's not an interesting scientific question anymore, right? Because we know that that's happening. But
Yeah.
there are still some people who are trying really hard to find evidence that it's not happening. And so the worst sort of analysis that I see, and actually I was contacted for a comment recently because it was on a government party's website in the lead up to the election.
Oh.
using these old observations without any consideration of how they were taken, why they were taken, where they were taken, whether instruments had moved, whether the thermometer was in the right kind of box. And they would say, oh, it was really hot in the 1890s, therefore climate change isn't happening. And, a part of me desperately wishes they were right. It would be so
Yeah.
great to say, oh, thank goodness. Yes, climate change isn't happening. Great. We can go and answer some fascinating scientific questions about how thunderstorms in Indonesia affect heat waves in Australia. And, that would be so cool. But unfortunately, that is a misuse of data without a consideration of the story behind the data, without any critical thought of how observation techniques might have changed over time and the uncertainties associated with those records. It's not to say it was never hot. Australia has heat waves,
Yeah.
but to draw such a long bow based on one station, based on 1 week of hot weather in the 1890s compared to today, I don't know, that's pretty bad science to me. And it's been debunked by lots and lots of people in lots and lots of ways, but it's sort of a story that keeps persisting, maybe because would be so nice to hold on to it, or maybe because there's lots of nasty vested interests. I'm not really sure, but yeah, that's something that I always think, oh man, come on, you could do better than that. We've been hearing this argument for a long time now. It's been debunked a lot. That's not doing the data any service.
It is human nature, though, isn't it? That we we want it's confirmation bias. We look for things that support the thing that we want to be true, and it's something that I think, as scientists, we have to be particularly wary of, because knowing your own biases and knowing about confirmation bias and all that stuff doesn't stop you being subject to it. So, we have this pull. One of my favorite books on the topic is Predictably Irrational by Dan Ariely, and he talks in there about all of these ways in which our brains kind of trick us and trip us up. And he repeatedly uses examples where, and this happened to me just the other day, and I study this stuff. Like, I study this stuff, I know it really well, and it still works on me, and that should not be a thing. That's just unfair. But I think as scientists, we sometimes fall for the story that we are objective and unbiased observers of truth, and that's actually, we're human beings. We can't be objective and unbiased observers of truth, and we have to constantly be aware that that's impacting the way we interpret things.
I totally agree. And I think that's a concept that you actually don't get exposed to, or I certainly didn't, until you're kind of down the line. A lot of people get into science because they're hunting for truth. They want that
Mm.
objectivity. They want the certainty. And when you realize that there is no true objectivity, you've chosen a particular topic to research for certain reasons, you've chosen a certain data set for certain reasons, you've chose to look at it in a certain way for certain reasons, you've interpreted it in certain ways,
Mm.
whether you realize it or not, it's kind of, it makes it very messy, but it's also kind of liberating, because you kind of think, well, this is just one way to explore this question. Here is the approach that I've taken to do it, just like with the data set. Here is
Mm.
why I've taken these observations. Here is the way that I've taken them, and these are the answers that I've got. It's the closest accurate observation that I can have. Yeah, but that's something that I'm not sure. It's so funny you say that. I was talking to somebody about this just the other day, about this, how to share this idea, or how to expose undergraduate students to this idea in a way that doesn't kind of give them intense vertigo. How to teach science students that they need to be critical, not only about the choices they make in the research they do and the data that they use, but their own biases as well. That's something that
Yeah.
I think is happening more and more, but it has to happen everywhere. And I think you see a lot of discussions now about Western science versus, traditional knowledge and Indigenous sciences. And there are discussions happening where people are kind of dismissing knowledge that's been around for tens of thousands of years. Oh, it's not science because it wasn't in a lab, or because it wasn't what written by a white man with a beard. Like, what are we looking for here? What do we accept as knowledge and as understanding? I think that's, I don't know, it's a really interesting time to be working in science, I reckon.
Yeah, I completely agree. You kind of, the example you gave of data mistakes sort of verges on deliberate misuse, although it may have been more less intent to mislead and more intent to be misled in some sense, and then they wanted to believe it themselves, and so that, that's what they ran with. Have you got other examples where you've seen data that's just been outrageously deliberately misrepresented?
Oh, look, I think I'm probably being a bit generous to the people who are still wheeling out these tropes of, oh, it was a hot day in Burke in 1896, or it was,
Mm,
there's some records in Adelaide in 1897 or something. There was a lot of heat waves in the 1890s in Australia. We had quite a few. It was the descent into a big long drought, and there were a few El Nino events in a row, which we know sets the weather systems up to cause more heat waves.
mm.
And I honestly think, I mean, I've been working in this space for nearly 20 years, and I've seen the same things being wheeled out that whole time, to the point where it is
Yep.
being deliberately misused. What did I see? I couldn't believe it, actually. I was at my in-laws' place and I was reading. I don't know who your sponsors are, Linden. Linda, I was reading Herald Sun. Is that going to get us in trouble?
The day I work with the Herald Sun is the day I just retire.
Anyway,
Like, no.
I couldn't help myself. I don't know why I did it. I read Andrew Bolt's column, and
Oh,
I
oh,
know,
when did
I know, I know, but I couldn't believe it. It was 2022, and I was reading this article, and I thought, didn't I read a very similar article to this in the late 90s when I was doing critical reading in English? Like, it was
Mm,
blatant use of emotive language and dismissive language. What was one of the points? Genuinely, in 2022, in one sentence, climate change isn't happening. The very next sentence, and even if it is happening, it's good. In the UK, there have been fewer
oh,
people dying because of the cold.
oh.
And I kind of was like, okay, there's so much wrong with that non sequitur. You're saying it's not happening, but then if it is happening, it's okay. I mean, I think Tony Abbott sort of did a lot of the same thing. But also,
Yeah,
statistics in the UK, how does that so many people die? More people die in Australia of heat wave related deaths than bushfires and floods and cyclones combined. You know, to use that information to put Australians at ease about the non-occurrence of climate change, it's a deliberate twisting and misleading and cherry picking of
yeah.
data. Oh man, I felt so sick. I regretted my reading choices over my breakfast that morning. But
You
yeah,
feel
it
like
was,
you need a good scrub, don't you? It's
oh,
like, get it off
exactly.
me.
But like, I'm kind of at this point now. So somebody, John Cook at the Monash Climate Change Communication Research Hub. He does a lot of work. I think he was working as an animator or a data analyst or something in Queensland, and he got into a barbecue conversation with his father-in-law, who was a climate skeptic over, I don't know,
Oof.
15 or 20 years ago. Yeah, right. So he was having these conversations with his father-in-law, and he was like, how are we having this conversation? And so he started this website called Skeptical Science, where he addressed a lot of these myths, either deliberate or not deliberate, kind of misrepresentations of climate data or climate science. And the website grew and grew and grew, and he ended up doing a PhD. And then he went over to the US working with some climate change communication experts over there. And now he's back in Australia working at Monash University in Melbourne. And he has done heaps of work about the deliberate kind of tricks that people use, cherry picking, or like the um, like that negative bias or a fallacy. One cold day, therefore climate change isn't happening, or all of these different approaches that are used by people who want to spread misinformation. And a
Mm.
part of me thinks that's really valuable, because the more you are aware of how data and how information is being used to tell stories in a certain way, the more prepared you are for those kinds of barbecue conversations, which I think are happening more and more. The momentum's totally changed. We don't have time. We don't have time for that small minority of the population who really aren't open to the fact that we need climate action, in my
Yeah.
opinion. But also, when it comes to that, setting up this dichotomy of us versus them, and the bad guys are using all of these techniques and the good guys are trying to combat them, that's not sometimes overly helpful either when it comes to
Yeah.
climate conversations. You need to be respectful with people, you need to have discussions with people, and even if somebody's read Andrew Bolt's article and has decided that that is the way that their truth is, um, it's a really messy place to then kind of say, oh, but he's cherry picking the data and I instantly dismiss you and everything you have to say and everything you believe in. That's not a helpful way to bring other people who might be like, there's no saving somebody like Andrew Bolt, for example. He's got a lot of
Yeah.
vested interests and stuff, but somebody else who's maybe a little bit further on that scale, um, a conversation is what you need to have, not a dismissal. Does that? I'm not really explaining that very well, but I think it's deliberate misuse of data is done by some people. Accidental understanding of misused data is something that happens a lot more.
Yeah.
Perhaps is what I'm
And
saying.
that you have to be able to have that conversation with them rather than just shut them down, and
Exactly.
as soon as you tell someone that they're wrong, you bring all of this kind of people dig their heels in, but they also feel kind of ashamed, like that, or that you're trying to shame them, that I can't be wrong, therefore I'm gonna have to dig my heels in, or if I am wrong it means I've been dumb and I don't want to have been dumb. So you just kind of reinforce all of the have to have to stand behind what I said.
Yes, exactly right. Yeah, and that's a really tricky space to be in, I think, and everybody
Yeah.
will address that or evolve the way they manage those situations in different ways over time.
Yeah. Is there something that you particularly look for when you're looking at data in the media, especially if it's not data that you're i- i- intently familiar with, and so straight away? Is there something you look for to sort of figure out? You see a graph or something. What are the questions you ask to try to verify or validate it?
I look for the source. I look for the data source. Um, yeah, I look for where the data have come from and the axes to make sure that the scale is something that makes sense. But I want to know where the data are from always.
Mm,
Where did you get that
mm,
information from? How far back does that go? You
yeah,
know, where did they get their information from? I think that's you can't just trust it on its visual representation, because they are, we say a graph doesn't change people's minds, and it doesn't really, but it can stick in people's mind as you see a
yeah,
line going up quickly or going down quickly or varying with
mm,
another line very closely.
mm.
Um, it does stay with you, and you kind of sometimes find yourself passing that information on without really digging into where the information have come from. So I always look for the source.
That's good advice. Do you think our understanding of data has changed over the pandemic? Do you see people responding? We all know the words epidemiologist and exponential now, but do you feel like that maps across to climate data and things? Do you feel like the overall attitude to data is different?
It's such a good question. What do you think?
Oh, you're not supposed to ask me
How
questions.
rude of me.
I think it sort of I tend to agree with Owen Churches, who I interviewed a while back, and he said yes, it changed, but it's also kind of falling off again. But also, I think a lot of what we've learnt has been quite narrow and focused, and sometimes wrong. So I'm not
Yeah,
sure that,
yeah,
I think it's good that people are aware that data matters. So people started looking for the data with COVID, and I think that's good. But
Yeah,
Understanding wise, we've got a long way to go.
I think it's definitely been hopeful to see data in conversation so much and to see it enter the news cycle, and for people, yeah, to become a little bit more familiar with seeing numerical information and have it being presented in the way that it has been presented. I also feel that from my side, from what I saw during the pandemic, there was a lot of hope that it would translate across into the climate space, but there's also a lot of fatigue, isn't there?
Mm.
You know, we're still tired, either physically tired because we're recovering from COVID, or absolutely exhausted because we've been living a very different life for the last 2.5 years. And the mental capacity for taking on board all that we've learned about how data have been understood during the pandemic and applying that to how climate information can be understood, and shared and lead to action is, I think it's something that would have been really great to have if we had the energy levels. But a lot of people have been surviving, just surviving, and maybe it'll take a little bit more time. I know. I guess there is more appetite for visually representing the data, but I don't know
Mm.
whether that's a pandemic thing or not. I think that's sort of an evolution of data journalism too.
Yeah.
Um, and that's also fed into big climate documents that are released. The latest Intergovernmental Panel on Climate Change report is much more interactive, has a lot more visuals that cover big pieces of information in probably a better way than any of the other reports have. But again, I'm not sure if we could blame the pandemic on that, or even maybe they'd be even stronger if the pandemic didn't come along and take
Yeah.
so much of people's time and energy. So I hope so, but I'm not 100% sure yet. I've definitely seen some good things, some good ideas, but I haven't seen lots of them put into practice yet.
Yeah.
But it does. I will say, sorry, I will say that the pandemic has shown us that we can act quickly and
Yeah.
dramatically for other people with a
Yeah.
positive outcome. Like we saw a problem, we thought, oh no, we have to do something about this problem, let's change the way we behave to stop that problem. That's what we need for climate change, the worst
That's
impact
a
of climate
really
change to
That's a
be
really
minimized.
key point, isn't it? We can do
Yeah.
it. We can, yeah, we can do things. We can do big things and we can do them really fast when we understand the need. And
Yes.
that's the key, isn't it?
Yeah,
I think
exactly.
that insight too about us all being exhausted is a really important one. And it is hard to take on new understanding and new ways of thinking when you're just trying to survive. It's a really important insight. Um, what excites you about data?
What excites me about data is the insight that they can give us. The ability to ask your own questions, right? If you've got a data set, you can explore it and say, oh, I wonder how this relates to this, and I wonder how that relates to that. I think data are, I don't know, I tell you that I love stories, and I do. Stories are how we engage people, but for me, I keep saying data is, don't tell Linda. Data are, they're the way we answer questions that we can then frame into the stories that we tell people. I love exploring. I love exploring a data set. I love being able to play with a data set to answer different types of questions. And I think there are so many data sets that exist in the world now. How many of them are deliberate or not deliberate? How many of them are trustworthy, not trustworthy? That's a big long question that you have to explore. But
Yeah.
once you've done all that, once you've done that 70% of your time of formatting it into a right place and getting rid of the 4 decimal places that don't make any sense, and making sure that the coordinates match up with the coordinates that you think you're supposed to have, and trying to make sure that the date formatting is correct so you can plot it in a way that makes sense. Once you can do all of that,
Mhm.
oh, you get to draw some graphs, and that's really exciting. That's really exciting to me.
You get to find things out. That's the
Exactly.
key, isn't it? Like it's the potential to learn new things that, I think most scientists are in science for that potential to learn new things, and data can possibly contain all kinds of new things that we haven't even necessarily imagined yet.
Yeah, and it allows you to explore things. I mean, I'm talking I'm talking about data sets that are large enough for you to kind of make some statistically significant statements at the end of them, right?
Mm, yeah.
I work with colleagues who work in different fields where their research is interview based, and they would
Mm,
interview 5 people. They'd do a content analysis of those interviews, and they'd pull out themes based from 5 people. And I
mm.
find it fascinating to me because when I see them present on their work, the scientific part of my brain, there's, well, 5 people. That's not enough to
Yeah.
make any kind of strong statement one way or the other. But then the way
Mm,
the stories are told, they stick with me. And I think, oh, yeah, wow, the way that family took on climate information and changed their behavior, and what we can learn from that's
mm,
really valuable. So as I move
mm,
further on in my career, you say what excites me about data, and it is the graphical stuff. But the more I learn about different fields that work with more qualitative information, which would still be considered data, the more I realize just how broad the spectrum is, and how you can still get useful information even if the p value isn't less than 0.05 or whatever.
Yeah, I find qualitative data so interesting because my computer scientist brain wants numbers and hard
Yes.
results, but the people side of my brain is like, oh, that's those stories, and that's so interesting, and often the qualitative research is where you find the things that you can then examine quantitatively. Like you wouldn't have even known it was a thing to look for if it wasn't for the qualitative conversation. But it's very easy to be um no, there's sometimes a bit of siloization between, qualitative and quantitative people don't necessarily talk to each other, and they tend to, be a little bit sneery at each other. Like
Exactly. Yeah.
we need both. We crucially need both. We can't get anywhere with just numbers, and we can't get anywhere with just qualitative, conversations. But the two together are so powerful.
Which is why it's so important that no matter your field, you need to learn how to talk about your work with people who aren't necessarily experts in your field, or who aren't passionate or even convinced. The school that I sit in now, at the University of Melbourne, ranges from cultural geographers who understand, who explore a single community's young people's population over the last 20 years or so, to people who study the last 4 billion years of the Earth's history using rocks, right? It's such an incredibly broad space, and
Mm,
it's so inspiring to me, maybe as an interdisciplinary person by nature. I'm just like, wow, this stuff's so fascinating. But to get everybody talking together, it can sometimes be a real challenge. And I think, like
mm.
you were talking about before, people need to overcome a lot of biases that they have built up over their lives or over their careers, to not dismiss somebody else's expertise just because it doesn't look like yours.
Yeah. Yeah, that's it, isn't it? It doesn't look like yours, therefore, you don't anything to do with it. This has been amazing. I worried when I first came up with the idea of the podcast, and I had the same questions for everyone. I thought we might just get, the same answers, and that won't be it'll be a pretty short series. But everyone has such a different perspective on things, and this is, I think your, multidisciplinary and cross-disciplinary approach is so fundamental. I've always said that's where the interesting questions are, on the borders and in the connections between fields. So this has been a wonderful episode. Thank you so much. It's just been fabulous.
Thanks so much for having me.
Thanks for listening to Make Me Data Literate. You can support the work of the Australian Data Science Education Institute at givenow.com.au/ADSEI. Tune in next time for more conversations with amazing data experts.